Right, today we're going to solve quadratic equations by factoring. So you can do it with graphing, and you see where it crosses the x-axis. Those are the zeros of a function. But today we're going to do that without the graph. We're going to do it by factoring. So here's the deal. If I can have these two sets of parentheses, and I can get one set of parentheses to equal 0, it doesn't matter what the other set equals. It could be -5. And 0 times -5 is 0, right? Same thing the other way. If I had 51 over here and 0 in the right set of parentheses, that would be 0, right? Because 51 times 0 is 0. That's the basic idea of what we got going here. It's called the zero product property. Product means multiplication. When you multiply by 0, it's 0. So look at this equation. X squared minus 3x minus 4 equals 0. You always have to have it equal to 0 when you do it this way. So we're going to factor it. Now if you look, our first term, our a is 1. So that's nice. So we can just look straight at that last number. If it multiplies to a negative, remember that has to be one positive and one negative. Now, factors of 4 include 1 and 4, or 2 and 2. Which set are 3 apart, the 1 and the 4? So to make it add up to -3, it would have to be -4 and +1. Perfect, it's factored. Now, from this step, after this example, you'll be able to get the answers really quick. But I want to show you kind of what this zero product property means. It's been a while. So if I can get this set of parentheses equal to 0, so if I can get x plus 1 to equal 0, then it doesn't matter what the right set would equal, because 0 times that would equal 0, and that would be true. Also, if I can get this right set of parentheses equal to 0, x minus 4 equals 0, then it doesn't matter what would be in the left parentheses, because 0 times whatever is 0. So we just solve both of these equations. How do you solve x plus 1? You subtract 1 from both sides. So x equals -1. Or, on this right one, we get rid of -4 by adding 4. So x could equal +4. There's our two answers. If you substitute either of those into the original equation, they both work out. So it's fine to have two answers. Sometimes you might just have one answer. Sometimes you might get no solutions. But that's what we're practicing today. So let me scooch myself over here. Now also, check this out. You might notice in the step where we factored, it says x plus 1. Maybe if I can underline that. So it says x plus 1, and our x answer was -1. Here it said x minus 4, and my answer was +4. So that's why I'm saying you really won't need to show the steps that we showed after that. If you can remember, x is always the opposite. So if it said x plus 7, then it would be -7. Kind of like when we graphed in intercept form, and the p and the q, it was like x plus 1. So you were like, oh, well, the y-intercept is -1. It's just like that. So let's try the second one. Look for a common factor first. There isn't one. So we need factors of 144 that add up to 24. So let's see, 144, we could have 1, if it'll let me write it, and 144. You could have 2 and 72, 3 and something. Let's see, 46, 48. You could have 4 and 36. 5 doesn't go in there. 6 and 24. 7 doesn't go in there. 8 and 18. 9 and 16. Or 12 and 12. And that's our set. So on the next video, we'll continue with that 12 and 12.